as the question says, find the center of mass of a uniform plate having semicircular inner and outer boundaries of radius r1 and r2. So as we all know that for center of mass, now this is symmetric about the y-axis, so obviously the x-coordinate is going to be 0. The only thing left is to find the y-coordinate. And we know that YCM will be summation of mi yi over summation of mi, right? So for this, let us take an arbitrary element over here. I think I should redraw it because it will be like this. In such a plate like this, I will be having an element like this. Now this is the element. Okay? And I need to put it, since I am having the element, I need to integrate in place of this summation. So I'll be doing it like integral of total mass of this plate upon total area of the plate, that is A, into the area of this element. Now what is the area of this element? This is basically pi r, the perimeter, like this length, into dr. Why I'm doing this is because you might be knowing that if here I need to approximate it as a linear strip. If you take it as a linear strip, you will be doing what? Length into breadth. The length is pi r, the length of this arc, and dr is its thickness. So length into breadth is basically the approximation. Because the strip is that much small that making such an approximation won't make a large difference in the answer. And then we will be having the center of mass of this element. Now this is actually a ring, and we have already derived that the center of mass for a ring is 2r by pi. So I need to integrate this thing, and I will be dividing it by the total mass, that is m. So m is a constant, it will be cancelling out, and so the answer is basically this. So I need to find out only the integral of, cancelling the factor of m, 2r square by a into dr from r1 to r2. And now the area is half, that is pi r2 square by 2 minus pi r1 square by 2. Now integrating this and putting the limits from r1 to r2, we'll be having it as 4 by 3 pi into r2 cube minus r1 cube over r2 square minus r1 square. Now let us factorize both of these. We will be having the term 1 r2 minus r1 in this and r2 minus r1 in this, and both will cancel out. Remaining 1 is left here. We will be r1 square plus r2 square plus r1 r2 upon r1 plus r2. Because the r2 minus r1 factor has been cancelled from numerator as well as denominator. So this is the answer for this question.